to another Random Code stream. I'm going to be working on this issue, which I hope actually turns into something kind of interesting. It's not a big feature, but it's something that I think in Rocks would be kind of a nice little value add. It's nothing major, but it's just one of those things to reduce a little friction, reduce a little paper cut, so to speak. So let me get my music going here. I have that going in the background. All right. So in Rocks, if you want to say that you want to be able to mock a type definition, you have to put in this attribute. And the reason why you have to put in that attribute is mostly in part because of how source generators work. You are highly, highly encouraged. There's probably like 3 other highlys I could put after that state that you need to use an attribute as the starting point or the kickoff to your code generation. And you don't want to be reliant upon anything within a syntax tree per se. And there's reasons why. I'm not going to get into them here, but that's what you should be doing. And initially Rocks was doing something like looking for a call to rock.create. Well, that's no longer the way it is. It changed, I don't know how many versions ago, but now you need this attribute here. Okay, so that's all cool. But if you want to mock a particular type, you have to remember to put this here. Now, what I've done on projects where I've actually used this library, Rocks, I'll create a file called like mocks.cs or something like that. And then I put all of the rock attribute definitions in there because they're at the assembly level. It doesn't make sense to put them in every single file. Okay? But then you have to basically say, okay, if I want this, I got to go into that file. I got to write this line of code. And I know, that's so hard to do. that's such a pain in the butt. But what if you could have your cursor on this type definition, for example, and I could do the control period and bring up a refactoring that says, hey, I'll put this in your current file. And maybe I'll be able to do this so that if you set something up in your project, a certain property, it'll say, I want you to do it in this file because that's where all of them should go. But I don't want to be just looking at type definitions. Maybe you're in code, for example, and can I just kind of like throw this out there? Let's actually go into a integration test to show this. Doesn't really matter which one. So let's say I wanted to write something like var x is equal to new abstract class property. Now, if it's an interface, you can't new up an interface, nor could you new up an abstract class. But just say I had that type here, and I could do dot to control dot. Well, nothing's showing up right now. Okay. Maybe what I could do is get it so that I say, hey, I want to have a refactoring here that says, you know, give me a refactoring. Okay. So if you look at when I'm clicking on here, see it's an identifier token. If you go all the way up, you're basically to an object creation expression. Even if I took that off and did this, you're going to still see an object creation expression syntax. Now, if I say view symbol, well, there's no symbol there. But there is a type symbol. So what's interesting about the compiler infrastructure in .NET is that it's, calling it tolerant is maybe not the right word, but it tries to do as much as it can, even in the face of errors. So even though this code is an error here, it still thinks you're probably trying to do an object creation expression. That's what it puts in as that node in the syntax tree. And I can tell that the type is, well, that's the instance constructor, but you can see a metadata name that it's kind of picked up on the actual name of the type. And if I come down maybe to something like even an interface, where I would say var x is equal to new interface method void, and I go into the syntax visualizer, and I click on this, you'll notice that it's still, if I do type symbol, it'll still give me that this is a type, even though this is an interface and you couldn't create an interface. So the point is that maybe I'm here. Maybe I'm on a type definition like right here. That's where my cursor is. Maybe I have, I'll just say string A. The strings can't be mocked, but you'll get the point. Maybe my cursor's here. And if I look at that, you'll see string keyword. That goes up to a parameter. And if I say, what's the symbol for this? It should give me a parameter symbol, where then I could look at the parameter type. And once I have that type symbol, whatever that is, then I can go through the rock stuff to take that type symbol and say, could I create a mock for it? And if I could, then I could offer up a refactoring to say, hey, and for now, just this file, let's put that assembly thing in, okay? Let's take this out because that's wrong. But I could potentially put in assembly, and I can already tell I have it in the wrong spot. Rock, interface. And that's the other thing. You have to have this, I believe, above there. Yeah, now it picks it up. And we want to say type of that. It's a build type create. Okay. Which is fine. I've already done this within this test project, so it's kind of worthless, but I don't stop you from doing more than one. I'll create only one of those, though. The point is, this has to be here, it has to be under your usings and before any of your namespaces, if you do it here. So that's the first thing I want to do, is I want to say, let's keep going up the syntax tree of whatever node you're on, and as soon as I find either that this is a class declaration, or maybe I say, or come up here and I go to this, this is an interface declaration. You have a class declaration, interface declaration. Arguably records could be as well. So I could have like a public record stuff. Okay. And if you look at that, that's a record declaration. That could be mocked, potentially. So, or we have a parameter. So depending on the things that we're at, in fact, I'm going to make a list here because syntax nodes to look for. We had a class declaration. And I think it's actually class declaration syntax. We have a interface declaration syntax. We have a record declaration syntax. We also had, if I click on this goes to a parameter syntax. And then, of course, we had this, which ends up being a object creation expression. Okay. Now, there might be more object creation expression syntax. And from here, again, we can do type symbol and we can get non-error name type symbol. So the name type symbol, we can get what it is. So the point is that I need to create a extension method that says, here's the current node I'm on, go up it, and give it a list of all the nodes I could look for. As soon as it finds one of these, you know, whether it's this or this or this or whatever, parameter syntax, it will then say if it's a parameter syntax, then get the symbol as a parameter symbol and then get the parameter type and return that I type symbol back or name type symbol back. And then if we can mock that, then we'll go through the code to say, okay, what I need to do now is actually generate the code for that assembly level attribute. And then we could also make sure that we have the right using statements in that file. If we don't already have it, we could also put in the rocks, using rocks, because we'll need that for the rock attribute itself, along with the build type. But the point of doing all this is, again, I should be able to, instead of remembering all that, I could just click on this and say, generate rock attribute, or whatever, however I want to specify that text there, and do it, it puts it up there, and now I'm done. And I got everything there. So it would be a lot less to remember, and it's a nice little helper when you're in an IDE. So that's the intent. Now I got to make it. In one of the previous streams I did, I was originally going to make a refactoring to deregionize code. I actually ended up making that an analyzer as a suggestion or information, because making it an analyzer gives you the ability to do that as a solution-wide code fix. So you can't do that with refactorings right now. If you watch my previous stream, you'll see that I mentioned that's not allowed. Although that's been asked as a feature request. So with this really isn't an analyzer I want to do everywhere. It has a very specific purpose, and all it is calling it a refactoring. Like a refactoring is typically, if you look at the definition, in fact, hey, look at that. Hold on. Over here, I've got one of my bookcases in my room. Move this picture over so I don't knock it off. Okay, got it. Got it. This classic book, Refactoring, from Martin Fowler, the one that kind of started it all. But it has at the beginning here, and I want to bring this up. I didn't plan on doing this, but he has it right in the beginning. What is refactoring? Refactoring is the process of changing a software system in such a way that it does not alter the external behavior of the code, yet improves its internal structure. It is a disciplined way to clean up code that minimizes the chances of introducing bugs. In essence, when you refactor, you're improving the design of the code after it has been written. Now, with what I'm going to do, is it technically a refactoring? No. Like a refactoring here, extract interface. Maybe that makes it better. Extract a base class. Maybe that makes it better. Moving it to a namespace. Taking something and making that into a local method, or saying all these constants, pull them all up, like these hard-coded constants values, put them up into a constant. Those types of things. That's where the code still works, but it's better to have all the same values defined as a constant, rather than as magic values thrown all over the place in your code. So this one technically isn't a refactoring, but it fits the best. So that's what I'm going with. All right. Let's move ahead with this. By the way, if you are watching either now or in the future, thank you for doing so. And if you haven't subscribed yet to the channel, please do so. I'd greatly appreciate it, as I'm trying to get to 1,000 subscribers as my first goal. So any new subscription helps. All right. So let's come into Rocks itself. And where do I want to put this? Let's put it here just at Rocks level, at the root level. I was thinking of maybe putting it into a folder that is like refactorings, but I think I'm just going to leave it here for now. We can always change it later. It's not something that a user would ever see. This is stuff that's loaded for you, so you don't do it. And actually, one thing I'm going to do in this 9.1 release is I'm also going to pick up the story to separate things out. So I have the right stuff in assemblies and in the package so that it's all separated out correctly. I'm throwing everything into one, and that's really not the way you're supposed to do it. And I want to do that sooner rather than later. So it will work for now, but we really need to separate that stuff out. So we can say add rock attribute refactoring. Okay. I don't need a license. I actually wish I would tell it to stop doing that. Okay. I forget the types that you need to derive from. That's why I put these as links here. This is one that I did for something, extract types to files, code refactoring provider. That's something that actually exists now within Visual Studio. So, but at the time I wrote this, my book, like 10 years ago, that didn't exist. So we have a code factoring provider class. Is that the one we got installed? Probably. Let's just say find and install latest version, because we're using central package management, so it should update things for us. Okay, and then it's going to say implement it. We do this, yada yada yada, and there we go. Okay, that's not really implementing though, is it? We also want to put these things on there. What is shared? Oh, this is on the wrong thing. This is on the... There we go. There we go. Okay. Missing XML comments. Yeah, whatever. And then we're doing... Yeah, so we'll get to the comments later. Da, da, da. Oh. No, you're not. Where did they go? Ah, that will shut you up. Okay. That'll shut you up. Okay. I do believe comments are a good thing. I just don't want to focus on it right now. So the other example I had here was from here. Actually, no, go back. I want to dump this into a different tab. Is some general variables needed for so we get our document. Kind of like this check, actually. Except... no. At some point, we are going to do an await, so we can just say return. And then we want to do that check. I'm kind of actually, like, I like things being in blocks. I don't like them being like one-liners, being on their own, but that's just a personal preference of mine. What do? I don't even get the span, but that's okay. We then get the root in the model. I'm going to get rid of the configure awaits though. We don't need that. Don't need that. Yes, I'm not using those yet, but we'll get there. So we got the rid of the syntax tree. We got the model. Now we want to keep looking up, and this is where I need to write that extension method. And I want to do those off of syntax nodes extension, where we want to say find parent symbol. That's really what we want. We want an internal static I name type symbol. Find parent symbol. Except we're going to say self here, but what we're going to have is params of a read-only span of type. Syntax nodes. Well, we know they have to be syntax nodes, but we're looking at them for types. So syntax node types. Okay. And so what we want to do is say sort of this. We're going to say while parent is not, basically while parent is not null. Okay. What we want to say is if we want to find var syntax node type match is syntax node types first. Oh crap, you can't do that on a span? I thought you could. Well, that sucks. I was almost positive that the link statements also worked on. Maybe they do, but they're not in standard 2.0. Mother effer. Fine. Do it the hard way. And what we want to say is find the first one. Where the current parent type, get type is equal to t. They are literally the same type. Okay. Now, if we don't have any, is not null. That means we might have a shot here. Okay. And so what we're going to do in this case now is we're going to say, okay, this gives you well, we've already found it. We know it exists. It's a type. I was just trying to think if you could do this as a switch expression, but one of them would be null and you want to break. I don't think you could do that, could you? And you don't want to break because you want to be able to do this. So if it's not null, then we need to say if is not null. Now here's the thing. I could make this a generalized method. But the problem is getting the type symbol is going to be different for each of the types that we're looking for. And well, I could leave it like that and then just say the ones that I actually do support. That's kind of weird. Like, I'm writing this not to be generalized. This is just for rocks. Type. Grab that. that. And grab that. You don't know what that is. I thought object creation expression syntax. Creation. Okay. Yeah. Okay. Sorry. Object creation. There you go. Now you're happy. All right, so those are the ones we're looking for. So now we can say if we did actually get a match, it's one of these. And it's the first one. We don't care, you know, for whatever reason, we're not going to, you know, we're just going to say the first one. Okay. So if type of yeah, we know that we have a match now, but now we have to determine which one we really want. So if we say parent switch, class declaration syntax, class syntax, sure. We could say no. And then this also would get back no, which is really weird. This is probably, yeah. Var parent symbol. No best type was found for the switch expression. Thanks. Preach. Big preach. Oh, we're also going to need the semantic model come in. Because in this case, excuse me, model get symbol info on parent. We could also bring in a cancellation token as well, which we don't have. Because, yeah, the context does have one. And so this gives us a symbol. That's an I symbol. Okay. And so now it went away because it's like, yeah, that's great. So we'll do the other ones. We're going to say, though, that if parent symbol is I named type symbol, return named type symbol. There. So at least that gives us what we're hoping we're going to get. And then we'll just say return null down here. And now that's all good. Okay. So the rest of these now, yes, you're going to complain. This one. That one. I mean, I guess we could just do that. This feels a little klutzy, but... Parameter would be different. We want to say go away. I parameter symbol. That's the cast. Dot param type of the parameter. May not be correct, may have to do a little alright, so if we do that, we put that in there, and we do this, and we do that. I guess we could do that and that, except here, my object, I'm not sure in this case what it would be. There's an operation, but that's not what we're looking for. Rx is equal to new object. Let's bring up the visualizer. An object creation expression. In this case, gives a method because you're actually saying I want it on like the constructor. If I did that, object creation expression, the symbol is going to be a method symbol. Yeah, and so we could basically say on the method symbol, what's your declaring, well, containing type. Maybe it is just containing type, the type that contains it, I think. Yeah, so we could say here, my method symbol on this. I always forget, is it symbol info dot symbol, or does it get there's like declared symbol? It's a symbol associated with a declaration. So maybe that's what we actually need to do for the declarations. Symbol info, say dot symbol, get this out of the way. The dot containing type. So what is the type that's actually containing this declaration? And so these are get declared symbol. Except for saying here this. Whoops. Okay, so I think we can get rid of that. If we determine that the parent is one of them, then we do a switch and we say if it's a class or an interface or a record, gets declared symbol. For a parameter symbol, we're going to get the parameter symbol's type. That's the type of the parameter. For an object creation expression syntax, we're going to get the method, the containing type. And if it wasn't any of these, for whatever reason, it should be, but we're going to just say no. Because eventually we'll go up to the top of the root and we'll fall out anyway. So there's no chance of this spinning. And then if the parent symbol is actually a name type symbol, then we'll return it as that. I don't know if that actually has to be that. Okay. So what we're going to say here now is var mock type symbol is this is this text span, and we want I forget. Find token. There. Thank you. Thank you. Thank you. Thank you. What we actually want is on the root, find node. Finds a node with the smallest syntax node full span that contains span. What is this looking for? A text span. I guess we should probably be yeah, they don't well, they do semantic. Okay, so wait, let me reverse this. We're going to do semantic model cancellation. They're just capturing that. Okay. And we should be doing something like this to capture whether we're actually doing cancellation requests, but we'll move on. So we'll get the semantic model. Let's put that check in here too. That's probably a good one to say return from. Except for some reason. What is that? Oh, that's their own thing. I guess maybe that would be fine, but yeah, I'm just gonna ignore that. They actually do this to get the root. We could say that var cancellation token is equal to that. So then we have that there and there. No, what? I want to say is, not. Okay. So we found the node, except what we want to do is we want to say on that node, find parent symbol. There. Now, if is not null, why is it? So if we actually found something, that's, yeah, I think that's how you say it. Hello, how you doing? If we do not find a null, that means we actually have something we could go with. And so now what we need to do, let's look at our generator. You say mock model create. The information is not null. showing a syntax now? Is it because of where I'm actually doing it? I forget. Again, I write code and I don't remember what I'm doing. So we could say create here. Syntax node would be, we should capture that. Our node is equal to that. So we'll say node. Parent symbol, create node. Type to mock, mock type symbol. Expectations information source. No. Model context. We could do that. Model. Actually, we could probably just pass that in here. Okay. So we're doing all this. And then if mock model.information is not null, this is mock model information, which is really, that's the thing that we're using when we create our mock stuff. Mock model information. Yep. So if we have that, that means that this is actually a type that we could mock. Now what we need to do is generate the document to actually, not generate the document, but create the code. And again, for now I'm going to assume that it's the tree that I'm in. I'm not going to try to do something to say find in the solution, if maybe something you're configuring in your project property settings, go use this file as like where the rock attribute should go. We're just going to assume here for now. Okay. So to do that, what we want to end up with is a new root node. This is going to be fun. What do we need to do in the document? The first thing we need to do is, because they may not even have a namespace in their document. They may not have any usings within the document. It's possible, unlikely, but possible. And that's one thing I've always remembered when I was writing this stuff is, what are the things that you have to be very careful about when you're assuming certain things? We want to make sure that here, that we're not assuming that there's always going to be using statements there. What we are usings is equal to root descendant nodes descendant to oh, that's right. We want to say here of type using syntax. Directives or statements? What are these? They are directives. A using statement, I believe, is when you say using within code. So we want using directives. Directives. So that good, and we want to have two mutable array. Okay. So, and again, if you look like within the syntax visualizer, well, I need that thing pinned. The root node is a compilation unit, and they're right under there. So basically, it's the last one. We get to the file scoped. That's where you start getting into that namespace declaration. We could also look for what's the, if there are no using directives, then we will put the thing right after the compilation unit. Otherwise, we should be able to say add using though, right? Maybe. Root. There was. Yeah. Hold on. The thing I'm going through in my head is in Transpire, there's actually a code fix that I think we want to do, and it has to do with the GUIDs. Find a new. The root has usings. Is that my own? Oh, it doesn't have the using of the GUID namespace, which would be system. Then we want to add usings. What is add usings? That's actually the new root. We should say if we say here root as compilation unit syntax add usings. We don't know if it's actually we need it. That's one to keep in our back pocket. And then you see there's a whole syntax factory using that. But that's not actually what we're curious about. What we want to do is add attribute lists and let it figure it out where to put it. So we need a new syntax factory. Can we say syntax factory parse attribute argument list? What does this need? This needs a attribute list syntax. Parse an attribute argument list syntax. We don't want an argument list. We don't want an attribute argument list either. Can we just say parse? What is an integration test here? Because I have that in my shared file. Nope, not the shared. Mock definitions is what I'm calling it here. These are what? This is an attribute list. So that's what we want, is add an attribute list. Parse attribute argument list. Parse an argument. Well, that's kind of what I want, right? What I want to say here is something like, what's all the complaining here? Oh no, I want an attribute list. Creates a new attribute list syntax. That's great. What I'd love to be able to do is give it just a piece of text and say parse it and give me what that is. You know what I mean? That would be ideal. What is that tool? There's a tool out there. It's written by, I think his name is... I haven't used it in so long and I forget what it is, but it's not a syntax visualizer. .NET Rosalind syntax generator. What is that called? Quoter. That's what it's called. Public class my attribute. Derive some attribute. And we want to have attribute usage. All this stuff I just don't remember off the top of my head. There's the rock attribute. So we want to do something like that. And then we say assembly my. Yeah, this isn't really that helpful. This is not quite what I was looking for. Where's that assembly going in? This is for the whole attribute list. That gives you the attribute usage. Here's the allow multiple. With the literal is a true expression. We have modifiers, base list, close brace token. Here is the trivia with tokens my. If we just move that up here, what happens? With attribute lists, assembly keyword. So come back here, we have add attribute lists. And we could say syntax factory. I think all of that. Red equals that. You say add attribute. What's the problem here? Cannot convert from attribute list syntax to attribute. It's a syntax list. What do we want to do here? We want to get but that's not quite what we want. Add attribute lists. So that is an attribute list syntax. This is a list. Okay, so maybe we don't need this. And then we don't need that. Hey! Sure, whatever. I think this is redundant here. Yeah. And then the target here is just saying that we want it at the assembly level. I'm wondering if we just said rock type of string build type create. What does it do then? For someone who has no idea what you're doing, can you explain? God, where to start? So what I'm doing in this stream and probably subsequent streams is I'm basically building a refactoring. This is something you can do in Roslyn. And basically whenever you hit like the control period in Visual Studio, you get these refactorings to show up. So I'm creating my own because with this rocks mocking library that I've created, when you want to generate all the code using a source generator for a particular type, you have to declare an attribute that looks something like this. And you don't have to give the full type name. I'm just saying it's the fact that you put this one line there, which isn't hard, but the intent would be is, hey, if I'm already on a type, could I just do control period and say generate that attribute for me? So that's the intent of what I'm trying to do here, because then that triggers the source generator to then create the the generated code that you need to do all the mocking that you want to do. So that's in effect what I'm doing here. And so this requires a whole bunch of, how do I want to say this? This requires a whole bunch of Roslyn API syntax tree addition, stuff like that. So if you're not familiar with it, it can get kind of convoluted, to say the least. And so this isn't the most trivial thing to do, but that's what I'm doing in this stream. So, all right. What I'd really like to do, let's just what would be the simplest way to do this? Sure. Console app 3 works fine for me. Really, what I want to see is if I say var x is equal to syntax factory. Come on, baby. Oh. She's not going to do it. I really thought there was a way to say syntax factory just parse. Because you can say like parse expression, and that gives you an expression syntax. An attribute list syntax is a C# syntax node. That's just a syntax node. So that doesn't really help. This isn't an expression, it's just is it a statement? It's not a syntax tree. Well, it produces a syntax tree. And then what we could do is because what we could say here is essentially exactly what we want, which is assembly rock type of, and I'm just literally going to do this right now. Build type create. And then we can say here, this gives you a syntax tree.root of type I'll be surprised if this actually works. Of type attribute list syntax. Attribute list syntax. Okay. There should be only one. Var attribute syntax is equal to that. And then we should be able to do that. That's much easier. Because here we can put in the name of the type that we found. Right? Var mock type name is equal to. Well, we don't even need to cap. We can just say here. We could parse it, and then we'll put in here. Not that. What we'll put in is the mock type symbol name. Now, let's close that out. Don't need it. Because I don't think I need it. What we would also want here is what I'm doing with this other thing, which is, does it have the using? If it doesn't have the using, so this is where we copy pasta. We come up in here and we say syntax nodes. Because we need to have a using rocks for both of these. And we need a using for the namespace of the type that the mock is in. So if we come back here, no, here, and we say, no. We need to do this twice. So if the root has usings rocks, then we need to do this. Okay, so that's fine. If we get all the way down to here, we can say var new root is equal to root. Because then we're going to keep replacing new root. New root equals off of new root. We're going to add in here rocks. If we also don't have the mock type symbol namespace, don't I have? Immutable hash set. Can't I just say here? Wait, what did this? Whoops. Hee hee. Var mock type names. I thought I had this already somewhere. I really gotta have this somewhere. Not in this file. What's this one? Get namespaces. Great. Where do I use this? Ugh. What is this doing? Gets the eyes. But then doesn't this have a containing namespace? Yeah. You know what? I know this isn't right. Containing namespace. I know that's not right, but for now I'm just going to go with it. And so we need to say root. If it doesn't have that namespace, then we're going to do that. Okay. Now hopefully this works. And we say .get root. The center knows. We find it. We do single. We just put that in there. We could have one for create and make. We'll get to that later. But we say on new root. Actually, let's just say compilation unit syntax as root. Because then we don't have to keep doing this all of the time. there. And so at this point, now what we can do is we can say, if we go back to the things that God, that's bright. Is we need to do the register refactoring. So we say context register refactoring. Register refactoring. Code action. Create. The title is add rock attribute definition. Extract type, create files. What is this actually? Code action factory. I don't know what their code action is. That something they're creating? Yeah, that's their own thing. Creative Funka progress. Create change to I don't. I don't quite understand off the top of my head what I did. What is the token? Move types to files and folders, and then we do this, which returns a task of solution. Immutable array. What's a code? Wait. The code actions within this group. Within the group. What the hell does that mean? I don't understand. Perform action. Applying refactoring means replacing parts of a syntax tree with under now. Let's go. So we got our document. We could say here document with syntax root, new root. Of course you don't like that. Can you just token is equal to task from result. There. Simple. This is totally simple, right? Easy. Or not. I have no idea if this is actually going to work. Just reviewing the code real quick. We're going to get the document. We get the span. We then get the model for the document. And we get the root. And then we find the node that represents that span. And then we try to find the type, if we go out to being something like a class declaration or an object creation syntax. If we find actually that symbol, then we determine is it something that we can actually create. And there's makes here. There's more that I can do here. I'm just trying to go down a simple path first. If we determine that the type is mockable, like an interface, that would be here. Now we get a new root. We're going to look through their root to get, do we actually use this anywhere? No, we don't, so we can take that call out. If it doesn't have rocks, we're going to add rocks. If it doesn't have the type, and this is a to-do, may need more here for the namespace. It's a lot more naming. But if that's not there, then we also do an add usings, basically saying, put that using directive in. And then we're hoping that this will work, that we're going to just say parse this syntax tree, which should just be fine. You should just be able, like, that will work enough that we're going to get off of this tree's root. We're going to look for that attribute list syntax. We should only have one, single it out, that's what we have here, and then we add it to our new root. And then we say to here, add rock attribute definition, saying the document that we have now has this new root in it, and off we go to the races. Now, I'll need to add tests, I'll need to add this to scenarios and all this other stuff. There's more work to do here. But for now, I'm going to leave it as is. Let me just make sure that my unit tests and my integration tests don't break. Like I changed the, yeah, see. Compile extension of assembly containing reference to workspaces. Yeah, and this is exactly what I'm getting at with detected package version outside a dependency constraint. Well, that's wonderful. I don't want to do all the packages because these all come for the other app that I do a whole bunch of testing on. There's nothing to consolidate. What was the error? Did I? I can't win. Oh, God. Yeah, this is all leading towards that thing that I mentioned before about having separate packages, separate assemblies, separate projects for this stuff, because you're not supposed to do what I'm doing. And it's being kind of a pain. And use 1608. This may be dangerous. What now? Oh, fine. I've noticed this like in the last 6-ish months to a year, that sometimes you don't get wow. What's failing? Oh God, this is going to be a mess. Let's just try this. Yeah, I can't do this right now. The reason why I can't do this right now is what I'm suppressing here, what I'm like putting this in there. I'm causing issues. And what I'm causing an issue on is this refactoring, because we're using this, and that's causing, if you like, compiler extensions should be implemented assemblies with compiler provided references. And so if I look this up, and this is no, I know I've got to change this in rocks. That's a given. Types which would not be clear in somebody's getting references. You can read all this, but basically it's saying that compile extensions analyze associated or load correctly in all compilation scenarios. Depending on the manner, some assemblies may not be present during a build, and attempting to reference them will result in exceptions that prevent the compiler. Best performing validation is a fault. Yeah, the following compile extension points examined by this analyzer are denies. Some extension points, code fixes, and completion providers. Also, I think refactoring is a factor into that. These features may ship in the same package as compiler features, but should be implemented in their own assembly since they require a reference to non-compiler packages. Workspace common, which is exactly what I'm running into right now. So I think what I might need to do is kill two birds with one stone. Where did my... Here. So I briefly mentioned this at the beginning. And this, unfortunately, is going to lead to a big piece of work. You see, this may be a lot of work, but what I want is rocks to basically hold the generator and now the analyzer and everything that the generator does. Okay. Rocks support is everything I currently have in rocks that I don't actually need in rocks, but the generated code needs it. So I need to have an assembly or a package or however you want to say it that this project file will see how to make it work. Somebody's already done this. You know, somebody's already shown how you could have analyzers, code fixes. They actually put generators. They put them all in different ones, separate ones. But this is basically if I remember reading this right, this is basically shows the library packages the source generator when we use .NET Pack. Fine. We don't care about this. But you notice that there is this shared TFM specific one. I believe that's what he's calling as like the thing that is needed, because you see down here a shared CS project. So there's a project reference to that. You say false. But basically, there's this handlers thing here. And all this is that this is the thing that actually does the packaging. And if we go back up to source here, you'll see that there is just immediate handlers. There's shared generators, code fixes, analyzers. And then there's also this common thing, whatever. But the generators here, that only has a generator. The code fixes here should have the code fix provider. We don't have a code fix provider, but we have a refactoring. So the point is, I need to separate all this stuff out. I need to have them in their own things. And you should have for analyzers here in CS Proj. That should just be, yeah, .NET Standard. Yeah. So the problem with all this is that it doesn't necessarily remove any code per se, but it requires a lot of shuffling around of stuff, which is needed. It should be the way I did it in the first place, but originally I just had a generator. That's it. And only recently have I started to add more things into it. Arguably, the refactoring here that I just added, this is what's tripping it. This is what's getting it mad. Okay. And so what I probably should have here is what is they're calling extensions. I am getting so lost. Yeah. So they're calling these extension points. These are compile extension points. I'm losing track of where I have everything. Edit. So therefore I think I need one main rocks project that handles the bundling of other projects into the rocks NuGet package. These other packages, these other projects would be called. Naming is hard. Compiler, extensions, the generator, and generator, suppressor, and analyzer. The types that are used by the generated code at runtime. IDE extensions. The refactoring and any code fixes if I ever do that. Okay, so then the support one, like I just did gen code. Rocks, IDE extensions would have that. So I think I need to kind of do this work as well, and do it in parallel with what I'm doing right now. Because otherwise I'm never going to be able to get this to work. I'm going to constantly run into compilation errors. And that's not what I want. It's just a lot more work than I was expecting to do right now. But at the same time, I wanted to do this for 910. So what I might do, I wanted to do another random code stream tomorrow morning, but this one is kind of touchy, just because there's so much that could go wrong with this and get very confusing. Trying to think of the best way to do this. I don't know. At this point, I'm just going to stop the stream because I want to take a little bit of a break, and I wanted to actually do a Splinter Cell stream this afternoon. So I think right now I'm just going to stop. I know I have to do some package project reshuffling and make things easier to handle and put things in the right places where they should go. I just don't have that right now. What I might actually do is keep this in the branch that it's in, even though it doesn't compile. And then when I then do another branch for this package restructuring work, and have it based off of what, or maybe I just do it here. I don't know. I can't think of it, but I'm going to do my gaming stream in a little bit and let this simmer in my head for a couple of hours, and then I'll figure out what is the best way to handle this restructuring so I can actually get this all to compile and build and bundle and do everything correctly. So with that, I'm going to stop this stream for now. I want to thank everybody for watching, whether you're doing it now or in the future. As somebody made a comment, this stuff may not be the most obvious things in the world that you do in C#, but doing all these things within the compiler API with analyzers, with code generators, source generators, and stuff like that, it's powerful and fun stuff to get in place. So thank everybody for watching again. If you haven't subscribed to the channel, please do so. I would greatly appreciate it, as I'm trying to get to 1,000 subscribers as my first goal. So any subscription helps. So thank you in advance for that. Again, I'm going to be doing a coding stream in a little bit. I will probably be doing another random code stream tomorrow morning. I'll see where I am with this, but either way, I'm done for now. Thank you all for watching. Take care, and I hope to see you in the future.